are reviewing Concept 8. Two things I want you to know. Both Worksheet 8.3 and 8.4 are excellent examples of extra practice for all these problems. So there's lots of videos for both of those worksheets, and you can be practicing those particular problems again. There's really nothing special to these in terms of this page, other than there's just really one of each type that you need to be able to do. So I want you to look at both of these. Both of these have just one x in it, which means we're going to be isolating the variable. Both of these have both an x squared and an x in it, which means we either need to factor it, use quadratic formula, something along those lines. So I'm going to start with these two here. I do need to isolate the variable, which means I do need to use the opposite of Pemdas. And by that, I mean this is subtraction, this is multiplication, and this is an exponent. So I need to first undo the subtraction, then the multiplication, then the exponent. So I move the 1 first. I then undo multiplication with division. I then square both of these to undo the exponent. And then I simply solve by subtracting my 1. So 63, just one answer for this guy there. Let's look at the next one. Almost exactly the same process. It's just going to be different to undo this one here, but I have addition here that I'm going to undo first. So that would be subtract 3 on both sides, negative 10. I then divide both sides by 10. I square root both sides. That will undo the square there. Plus or minus I. So remember, square root of negative 1 is I, but anytime you square root, you get a plus minus. So our final answer is x is equal to 6 plus I and 6 minus I. So those are our two answers. You can write it like this, or you can write 6 plus or minus I. Either one is fine. All right, let's look at C. So C and D, remember, we have an x squared and an x, which means that we are going to have to, again, either use quadratic formula or factor. Factor is definitely easier if it's possible. So we're going ahead and move the 17 over. We do our diamond. We have 17 and 2. I can't do it. So we do have some options here. This particular case is actually a little bit simpler using completing a square. So I'm going to look at that first. And then I'll also, just for the sheer joy of doing it, do quadratic formula. So if I'm using completing the square, the reason this is a good candidate, this is even, and there's just a 1 in front of that. If I do that, I already moved the 17 over, so that's nice, it's already there. I need to divide by 2 and square, so I divide by 2, I get 1, I square it, I get 1. So I'm going to add a 1 to both sides. I'm going to now factor, square root, sign of the middle. Now I just square root both sides. I get x minus 1 equals plus or minus 4i. And x is equal to 1 plus or minus 4i. So that is completed in square. It takes like 2 seconds, and you're golden. Now, say you don't like that, and you want to use quadratic formula. That's cool. We have negative b plus or minus the square root of b squared minus 4a, gotta move it over, c, all over 2a. We have what? 4 minus 4 times 17, seriously. See, let's go the other way, so much better, 68. So we get plus or minus square root of negative 64 all over 2. So we have 2 plus or minus 8i over 2. And then we reduce, 2 goes into here and here. This ends up being 1, and this ends up being 4i. So you still do get exactly the same answer. You just have a little bit more chunky math to do. All right, here's our last one. Probably going to be factorable since we are trying to give you one of each, but we'll see. We have negative 15 up here and negative 6 there. 1 and 15. 3 and 5. Just kidding. Apparently, it is not practicable, so we will use our quadratic formula again. All right, so quadratic formula, let's do this. We end up getting negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes, let me just say, pop goes the weasel for you. 6 plus or minus, we've got 6 underneath, we have 36 minus minus, so that's going to be a plus. Plus, what, 12 times 5 is 60, but I'm just going to make sure, because I would hate to be wrong on a video. It is 60, so 60 plus 36 is 96. I know you want to, but you can't, so you need to simplify this first. So let's see, 96 divided by 4? That works. 4 and 24, but 4 goes into 24, so I bet 96 is divisible by 16. Always check it. It is, we'll do 16 and 6. The square root of 16 is 4. The square root of 6 is 6. And now I do need to reduce. So you can just put those together, and then put those together, and that's 2/3. So you can have it that as your answer, or you could say, well, the only thing that actually goes into all 3 of them is 2. So that would be 3 plus or minus 2√6 over 3, and you can write it like that. These are both equivalent, because if I multiplied by 3 over 3, I would have the common denominator in 3 plus or minus 2√6. So it does work. Either way is totally fine. All right, our last one, little peeps. I know you look at that and you're like, it's a fraction, I can't do it. Yes, you can. Not a problem. There is only one x, so we can isolate it. So we move the 10 over, negative 10. Now, this is 1 divided by 10, so I can multiply by the reciprocal, which is 10 over 1. 10 over 1. Those cancel. See, no problem. Just do the opposite. It's division, undo it. This is equal to negative 100. When I square root, I get x is equal to plus or minus 10i. I because it's negative, 10 because it's 100, plus or minus because it is the square root. So these are both of the answers to the problem. See? Good luck.